All right, class, welcome to Math 2020, section 2.3, handout on symmetry and triangles. Okay, so here we're going to go through the handout and do some example solutions. First, we have this activity where we're going to sort these triangles based off of characteristics that you determine. So I encourage you to pause the video, take a look at the triangles, see if there's anything in common that you see. Could be from the sides, the angles, anything about their shape that you see in common, and write the letter in each of the categories. I have done 6 example categories, and you can use less or more if you want. So pause the video and see how things go. Okay, this is the type of activity that I like to do. Sorting is a good mathematical activity. Attenuating to certain characteristics is a good mathematical activity. So let's go. As I glance over all of these triangles, I notice that some have, there's a couple that look like they have all the same side length shapes. All the side lengths look the same. So we're going to kind of go through and mark some of these here. Now with one mark on a triangle, between two sides, or three, that means that they all have the same size. Okay, so these three on triangle D look like they have the same side length. And so I'm going to mark them with one mark. And it looks like that there's another triangle H that also has the same size sides. So I'm going to mark them with one mark. And since it's just one mark within the same figure, they're all the same. But between D and H, those one mark sides are not the same length. So it looks like that we have a couple of triangles where all the sides are the same length. So that'll be my first category. All sides are equal in length. So that's D and H. Taking a look at some of the other ones, it looks like there's just some that have just two side lengths the same. So I'll mark those with one mark as well. Let me back up here. I'm going to use red. Okay. Now this other one here does not look like it has the same length as the others, so I can put 2 marks on it. So F looks like that. Let's see, J looks kind of like that. L looks kind of like that. Maybe K looks kind of like that. Now it's not going to be perfect. Maybe I. Some of them aren't going to be perfect here. C. A. Yeah. I think that'll be about all. So this is 2 sides equal in their length. We got a lot of them. We have A, we have C, F, I, J, K, L. And then going by a pattern here to help establish a pattern, look at the patterns. All sides are equal, 2 sides are equal, and then one side is equal or no side is equal. Okay, so that's going to be the rest of them. They will have all sides different, same length. So there's 1, 2, 3. Okay, so I'll do 1, 2, 3. Do 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so that's all of them. That one's going to be no sides equal. We have B, E, G, and M. Those have no sides equal. Well, with triangles, we can look at their sides, and we can also look at their angle measures. Okay? Let's take a look at some of the angle measures. Let's use purple. Let's see, angles. Angles. Well, some of these look like they have angles that are right angles. Okay, let's try A. Take a look at right angles. Now, right angle in the triangle is 90 degrees. So it's impossible for a triangle to have two right angles, because two right angles is 180 degrees total. And all of the angles in the triangle need to be adding to 180, which is 3 angles. Right? So these ones, some of them look like they have right angles. We'll just go ahead and assume that they are, if they're kind of like at a right angle there. Some of them might not be perfect, but the idea is just to get the concept down. Let's go this here back up to here. So I'm marking these with purple. K might have one. Okay, so that's good. So we're going to do right angles. Right angle. So a triangle that has a right angle was A, C, F, K, and G. Okay, so right angles. Let's see, there's, for angle categories, there's acute angles and obtuse angles, which are bigger and smaller than right angles. So let's go ahead and go to another type of category here. Now let's go up to obtuse angles. Here's a big one right there, big obtuse angle. Here's an obtuse angle. Here's an obtuse angle. Now, since obtuse angles are greater than 90 degrees, there can only be one of those as well. So we do obtuse angle. Triangles with obtuse angles. So B, N, M. And category number 6 will be acute angles, where all of the angles are acute. So do orange for that one. All of the angles are acute. Let's do a lighter orange. Okay, and that would be the rest of the triangles. So if they don't have obtuse, so here's some that have all acute angles. And all those are acute. Yep, all these are acute. All of these are cute. All of these are cute. That one's obtuse, that one's obtuse. That one's right. All of these are cute. Okay, so it looks like we have them all. Acute angles. That would be D, E, H, I, J, and L. Okay, so great sorting activity. Moving on to the next page, we need to do some definitions here. And types of triangles. So categories based off of angles, like we saw. First one is acute. All the angles in triangle. Acute triangles are all angles are less than 90 degrees. So a triangle whose angles are all acute or less than 90 degrees. Right. A triangle that has one right angle. more equal to 90 degrees. And then obtuse is a triangle. Obtuse triangle is a triangle has one obtuse angle. Or greater than 90 degrees, but less than 180 degrees. You can also have triangles that are categorized based off of their sides. So an equilateral triangle, all sides are equal. Okay, and I'm going to go ahead and draw these ones again, equilateral. Usually look like this. All sides are equal. Isosceles. No, it's interesting to spell isosceles because there's SOS in the middle. So you say like, help me to spell this triangle name. So it's ISOSCELES. An isosceles triangle is a triangle with two sides equal. Okay, so there's an example of one. So two sides are equal there. Scalene is a triangle with no sides equal. Okay. Now, because we have these types of triangles, we're going to generate two new properties to add to our list. Okay. The first one is base angles of an isosceles triangle. And if you can take an isosceles triangle and cut it out and fold it, you'll see that it has that the two sides will match up, of course, because they're equal, and then the angles will also equal. So here's kind of like a little example of that. So I'll take my triangle, cut it out, and notice that these two sides will match up because by definition, isosceles triangle has two equal sides there. And then I'm going to fold it in half. Along the dotted line. Okay. And I'm going to kind of draw this out a little bit to show you that that will match up folding. Okay, so those ones are matching up. So they end up all matching nicely. Okay. So that's how you fold it and you match them up. And then you can see by inspection that they are equal. So the property is the measures of the base angles of an isosceles triangle are equal. Oops. Okay. How I'm going to use it is I'm going to say that the base angles like A and B, so I'll write A and B here. A is equal to B. You just say that the two angles are equal. Okay. The abbreviation is in parentheses, of course, so you do base angles of isosceles triangle. ISOS is the abbreviated form of isosceles, and you use a triangle symbol. Okay, so there's a new property. On the last page here, we have equilateral triangles. This is the base angles property we'll use a lot, but equilateral triangles we won't use very much. but by inspection one can take an equilateral triangle and by rotational symmetry verify that all of the angles are of the same measure. Thus, three angles of the same measure sum to 180, and each one will have to be 60 degrees. Okay, so here's our example with that. I take my triangle, and I'm going to label each of the angles a different letter, A, B, and C, and I'm going to rotate it 60 degrees. Okay. In this direction. That one will go that way, that one will go that way. Actually, I'm going to rotate it 120 degrees. And that's the rotation. Okay, so we go that way, and that way. Now, when we rotate 120 degrees, we actually get it back into the same position, but this is going to be angle C, this will be angle B, and this will be angle A. Rotate 120 degrees again. Okay, here's our triangle. And C is going to be down here, B is going to be here, and A is going to be up here. And then if we rotate it another 120 degrees, and get back to our original position. And since we rotated it 120 degrees 3 times, 1, 2, 3, we will get that A is here, and B is here, and C is here. Okay. Get back to our original position. And so they all match up. If we were to compare each one of these, lay them on top of each other. So the property is each angle in an equilateral triangle is equal and measures 60 degrees. Okay, which is from taking all the angles in a triangle, which is angle sum of triangle, 180, divided by 3, and you get 60 degrees. And so the use on this one is that any angle, A is equal to B, is equal to C, is equal to 60 degrees. Okay. So I'm going to divide this up here. Okay. And the abbreviation for this property is EQUILAT, equilat triangle. Okay, so you can say that any of the angles A, B, and C are equal to 60 by the definition, or by the property of equilat triangle. Okay, so that's our video for today, and I hope you guys enjoy, and we'll see you in the homework.